Okay, for some reason, Wyzant's not posting the question on the whiteboard as I start this video, but here's the problem. We're given the function y equals the square root, the cube root of x squared minus 81, or the quantity x squared minus 81 raised to the 1/3 power, and we're supposed to find the inverse function. Before we find out the technique for doing that, I want to go to Desmos and show you the graph of that function. The red graph is the graph of y equals the cube root of x squared minus 81, and is a function because it passes the vertical line test. But the truth is it doesn't have, as defined, an inverse function because it doesn't pass the horizontal line test. If I graph the inverse function as defined here, and by the way, that's how we're going to start doing this back on Wyzant, is interchange the x and the y. And if I plot the point 90, let me do it this way first. 90 is on the graph of the original function. That means the point 09 should be on the inverse function. And if I highlight the inverse function, 09 indeed is on the inverse function, but so is 0-9. So the way that we get around, and so that's not an inverse function because it doesn't pass the vertical line test. But if we restrict the domain for the original function, then it will have an inverse function because it does pass the horizontal line test. Or someday when you're taking calculus, you'll learn that if a function is always increasing or always decreasing, that it will have an inverse function. So similarly, I can restrict the domain of the inverse so that we get something like this. And a function and its inverse are reflections of each other in the line y equals x, and that sort of looks to be the case. This is the definition of the function that's the inverse, and you can see that it matches this one right here. Identical. So the question is, how do we get this definition, y equals the square root of x cubed plus 81? By the way, if I put a minus sign in front of it, you'll get the other half of the inverse function, but there's the positive half. So how do we get from here to this definition, y equals the square root of x cubed plus 81? Well, the general technique when you're finding an inverse function is to interchange x and y and then solve for y. How do we isolate that y? That's the question. Well, if we raise both sides to the 3rd power, we get rid of that fractional exponent. And by the way, what you're visualizing is this. We're raising both sides to the 3rd power. You don't necessarily have to show that, but that's what's happening. And when I raise this power to the power of 3, I would multiply these exponents, and that would become a 1. That's, in effect, how I got rid of that fractional exponent. Now, if I add 81 to both sides, I get y squared equals x cubed plus 81. And now I have to take the square root of both sides. Well, the truth is I could write plus or minus the square root of x cubed plus 81. But there's certain numbers for x that we can't take the square root of. But the fact is, if we want to have a function, we're going to eliminate the minus sign like we did on Desmos. Okay, so I'm going to stop sharing.